Good morning, students. The next topic we are going to see is about rolling motion. So, what is a rolling motion? It is the most commonly observed motion in our daily life. The motion of a wheel is an example of rolling motion. We know that a wheel, when it is moving, it moves in a rolling way, is it not? And also the round objects such as ring, disc, sphere. So these are all suitable for rolling. Okay. So when we consider a disc or a ring, whatever it is, and if it moves and that moves in the rolling motion. Okay. And in this rolling motion, what are the two things we have to know is it consists of two types of motion in it. They are translation motion and also the rotational motion. So what is the difference in this translation and rotational is, if suppose this is a wheel, okay, and this wheel, it will be rotating like this, is it not? And if it is rotating in this way, that comes under what? The rotational motion. So while it is rotating, what happens? It also moves in a straight path, is it not? Suppose consider that this wheel is in this position, okay, and after some time it rolls on, is it not? So while it is rolling, it moves in this way, but it also displaces its position, is it not? And that is called as a translational motion. Okay, so in rolling motion we'll be considering with the two things. They are translational as well as a rotational motion. So let us consider a rolling of a disc on a horizontal surface. So first let us consider a horizontal surface. Over that we are going to consider a disc and consider a point P on the edge of the disc. Okay, so this is a point P and this is at one edge. While rolling, the point undergoes the translation motion along with its center of mass. So, in the point என்ன ஆகும்னா மூவ் ஆகும், ஓகே, அண்ட் தெர் வில் பி டிரான்ஸ்லேஷனல் மோஷன். டிரான்ஸ்லேஷன் மோஷனும் எங்க இருக்கு? சென்டர் ஆஃப் மாஸ்ல இருந்து அப்படின்னு சொல்லியிருக்காங்க. அண்ட் த ரொட்டேஷனல் மோஷன் வித் ரெஸ்பெக்ட் டு இட் சென்டர் ஆஃப் மாஸ். ஸோ இந்த சென்டர் ஆஃப் மாஸ் அப்படியே வச்சுட்டு இந்த ஆப்ஜெக்ட் என்ன ஆகும்? இட் மூவ்ஸ் இன் த rotational way. So the rolling motion consists of what? Both the translational as well as a rotational motion. Clear? So combination of translational and rotational. We'll now see with the translational and rotational in this. If the radius of the rolling object is r, so consider that this is a rolling object and this rolling object has a radius to be r abdina, then in full rotation, consider that this is making one full rotation. So full rotation is starting from this and ending at the same point. So it is making one circle. So circumference of a circle is what? 2 pi r. So we can say that it displaces by 2 pi r. Okay, and one would agree that not only the center of mass but also all the points in the disk are displaced by 2 pi r. So இதுல center of mass மட்டும் displace ஆகாது, but all the points in this surface will get displaced for full rotation. Okay, the only difference is that the center of mass takes a straight path, but all the other points will move in the rotational way. So center of mass மட்டும் எப்படி இருக்கும்? நம்மளுக்கு straight தான் move ஆகும். How it is moving straight is, see here. So this is the center of mass, and if this object is rolling also, the center of mass is in this way. Okay, same way if the object is moving here. Okay, so the center of mass is moving in a straight path, all the other points are moving in the undergoes a combination of translational as well as a rotational motion. Okay, especially the edge undergoes a path of cycloid அப்படின்னு சொல்லியிருக்காங்க. Okay, next, as the center of mass takes only a straight path அப்படின்றதுனால its velocity has only the translational motion. So velocity for center of mass is equal to what? Velocity of translation எழுதிருக்காங்க. Why we are taking only translation? Because the center of mass is moving only in the straight path. Okay, all the other points have two velocities. One is translational and the other is what? Rotational. Okay, so one is translational and other is rotational velocity. That rotational velocity is equal to what? R into omega. This we have seen already in the relation between linear and angular velocity. What is the relation between linear and angular velocity? Is V is equal to R omega, is it not? Where V is the linear velocity, omega is the angular velocity. Here instead of V we are writing as V rotational, which is equal to R into omega, okay, and here r is the distance of the center of mass and omega is always what? It is the angular velocity. Clear? So we have got the equation for the v rotational. Now the rotational velocity is perpendicular and it acts in the center of mass அப்படின்னு சொல்லியிருக்காங்க. Okay, and so this is the path followed by any particle which is rotating. See here, this point first let us consider with this point, okay, so this point is moving in the circular motion. So if it is moving in the circular motion, what happens is it moves at the topmost point, then again it comes in the down, okay. So here this point it moves in the topmost அப்படின்றதுனால it is being represented here, then again it moves down, is it not? So it is moving down here. So this point is moving in the rotational, so it is moving in the rotational way and that value is equal to what? 2 pi r, okay. So the object rolls one revolution without slipping. We'll just see with this word slipping, sliding in this chapter now, but just know with this, without slipping it moves on. And see here, what about the v of cm, that is velocity of center of mass? Center of mass எப்படி இருக்கும்? In pure rolling, the point of rolling which comes in contact with the surface is momentary at rest. So whenever the object which is in contact, the point which is in contact, it comes to rest, okay. And again if it is moving to the top, then it moves, okay. Then again if it comes to the bottom, so எதெல்லாம் நம்ம எந்தெந்த சர்ஃபேஸ்லாம் வந்து காண்டாக்ட்ல இருக்கோ that surface will be at rest, okay. So that is with this point. Then we can consider the rolling in two different ways. So what are the two different ways? Is first one is the combination of translational and rotational about the center of mass. So from the center of mass we are going to consider the translational as well as the rotational motion. Then next one is momentary rotational motion about the point of contact. So from the point of contact only the rotational motion. So these are the two types of rolling motion we are going to see. Yes, so see here, this is only about the center of mass. So center of mass move ஆகுறதுனால all the points will be in the translational motion. So எல்லா point ஓட translational motion எப்படி இருக்கு? It is in the same direction as the center of mass. Center of mass எந்த directionல இருக்கோ எல்லா points அதே directionல இருக்கு. So this is translational motion. Same way when you are considering for rotational அப்படின்னா, then rotational each and every point it rotates, okay. Here it is rotating in what? It is rotating in the clockwise direction, so it is moving in this path, okay. So just see with this point, in the point மட்டும் பார்க்கிறோம் நம்ம இப்போ, okay. So seeing with this, see the translational as well as the rotational motion. So translational is in this way and the rotational is in the same path. So when you add this both, this is v of cm and again this is v of cm, so we are getting as 2 into v of cm since both are in the same direction. Same way when you are seeing for the next point, let us consider with the next point to be this one, this as well as this, okay. So this is for translational and this is for rotational. So அப்படி இருக்கும்போது அதோட ரிசல்டன்ட் இது ரெண்டையும் ஆட் பண்ணி வர ரிசல்டன்ட் எப்படி இருக்கும்? It will be along this direction. So அதனால தான் இந்த மாதிரி ஒரு direction same as this இல்லையா? So இந்த directionல it has been drawn, okay. So this is for the second point. Clear? Same way next take with this, yes, and this is in this direction downward and this is again in this direction, same as the before one. Take the resultant, result is acting along this direction, so we are drawing like this. Clear? So in the point நம்ம என்ன பண்றோம்? We are taking with the resultant, so resultant we are drawing. Clear? And the last one is the bottom point, okay. See here, this is acting along this direction and this is acting along negative direction. So negative minus v of cm, okay. So this is acting along this direction. So this is plus and this is minus. So they get cancelled. We get the value of the resultant to be 0. Clear with each and everything? So this diagram is very, very important one, okay. So only if you know with how to draw this, you'll be able to draw this diagram. Just make clear that we are just going to add with this two things, okay. So ரெண்டு diagram you add panni, we are getting with this resultant. Okay, so this both are acting along the same direction, so we are writing as 2 VCM. Same way here, this 2 points resultant this one. Okay, and the next 2 point resultant is acting in the downward direction, and the last one, they both are in the opposite direction, and so the velocity is considered to be 0. The point of contact is momentary rest in pure rolling. Its resultant velocity is what? 0. நம்ம இப்பதான் பார்த்தோம் resultant velocity 0 ஆயிடுச்சு அப்படின்னு சொல்லிட்டு. And at the point of contact, V translational is forward and V rotational is backward அப்படின்னு சொல்லியிருக்காங்க. So point of contactல நம்ம இப்பதான் பார்த்தோம், this is in the both the direction. So this is considered to be what? V translational, because it is moving in the forward direction. Then this is a V rotational, and the V rotational is acting in the backward direction. Clear? This implies that V translational and V rotational are equal in magnitude and opposite in direction. So on the diagram pati sonaliya, that is what in this paragraph. Okay, so V translational minus V rotational, that is equal to 0. Hence we conclude that in pure rolling, for all the points on the edge, the magnitudes of V rotational and V translational are equal. அப்படி இருக்கிறதுனால we are writing the equation for V translational, which is what? V of Cm. Then V rotational, V is equal to R into omega. So this is the equation which we saw in the first itself. It's not. So we can also write this as V of Cm is equal to R into omega. Clear?